Sir, I think yes. No, there was no assignment. I think.
Assessment.
Oh, assessment?
What?
No
No
assessment.
assessment. Okay, chalo, कोई बात नहीं. So in this class, we'll be having an assessment, right? So, so how many of you did the homework?
Not me, sir. I had exam.
चलो ठीक है. Anyone else? Farhan, Sara, Sitko? Sorry, Irshad. Why is everybody silent? Chalo, let's see. So it seems like you are a little bit like it seems like you are just exhausted because nobody is like replying to me except that Irshad is muted, Sara is muted, Farhan is muted, Safiya is muted. If you are in the class, just be active, na. 1 hour. This is only 1 hour class, and if you will be like very lethargic as well, like non-active, so the class will be just nothing but boring, right? So if I just wanted to make the class as like as much interactive as I can, but I need your you can say the contribution as well. Okay, chalo, that's it.
Yes, sir.
Okay, so next thing is that, bacho, just a moment. Okay, so we were doing the gravitation. So universal law of gravitation. Acha, there is a basically relationship between the gravitation and the Newton's third law. So in the last class, as I've told you that each and every body in the universe exerts the force on each other, and the all universe also exerts the force on each on the body. Right? Suppose Asitva is sitting in the basically in Abu Dhabi now, Asitva.
Yes, sir.
Huh. So suppose that Asitva is sitting in Abu Dhabi. So basically, whole universe, basically all planets, galaxies, like exoplanets, all are exerting force on Asitva. Sure. And Asitva, a single person is also exerting the same amount of force on the bodies as on the whole universe. Right. So this is a mutual thing. Okay. So everybody is involved in it. Even Safiya is involved. Even Sara is involved. Farhan, Irshad, and all the things. But in this basically the one assumption is there that we use this universal law of gravitation for the spherical masses or the point mass. So we assume that body is a point mass. It's just like a point because that helps us to calculate more efficiently. Because if we do not assume that, so we have to consider the volume, size, and all the things. So these things are not involved and not considered in the formula. So that's why we assume this thing that the body is that spherical or point mass. Am I clear?
Yes, sir.
Okay.
Yes, sir.
Let's do one thing. Okay, now let's understand one topic that is the relationship between the Newton's third law and the gravitation. Okay. So Newton's third law of nothing but it says that every action has an equal and opposite reaction. Irshad, Farhan, and Irshad, Farhan. I said something, bacho, that please switch on your video, but still you haven't switched on the video. If you're in the class, if you have any like problem like with the network, so it's acceptable. But if you're in the class without any issue, like you are not switching on a camera, so that's not good. Please consider this thing as well. Okay. Farhan, switch on your videos as well. Okay. Okay. The thing is that let's do one thing. So basically, third law of motion holds good for the gravitation as well because when the Earth exerts a force, so the object will also exert the force in the opposite direction, right? Suppose that Asitva and everyone, Sarah, Safi, and Irshad and Fran, suppose that a ball is falling towards the ground. is the ground. Ball is falling towards the ground because earth is exerting force. So that's why ball is basically coming downwards due to the pull by the earth. Yes or no?
Yes, sir.
Yes, sir.
Okay. So
Yes,
now
sir.
everyone, so it means that if it means that earth is also basically exerting some force, that's why there is an acceleration in the body, that's why it is moving towards the ground, that's why earth is pulling it. It means that there is a force coming from the earth. It means that earth is exerting some force on the body. Am I clear?
Yes, sir.
Yes, sir.
Now, have you seen like so same amount of force will be exerted by the body on earth as well. But due to the massive size of earth, that force or that acceleration is not observable. Acceleration in the body, small body is observable. You must have seen this thing when you drop a ball, so it will basically come downward with a very high speed. If you drop a ball from a fourth floor, you'll see this thing that ball will basically fall through it very stages. Okay, will with a very high speed. Yes or no, everyone?
Yes, sir.
Right? So that's why, but the same amount of force is exerted by the body on Earth, but due to the massive size of Earth, so that acceleration, that force is not visible to us, right? So that's why electric acceleration produced and the you can say the force generated, force exerted are same. But the thing is that due to the mass, it is not visible in the Earth case, but it is visible in the smaller body case. Am I clear to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, that's it. Hi Tejas, how are you?
I'm fine, sir.
Okay,
How are you, sir?
I'm good. I'm good. Sure, that's great. You have joined late. Please focus in the class. Okay, Tejas?
Yes, sir. Sure, sir.
Okay. So the Newton, third law of motion, also good for the force of gravitation. Okay. Means that Earth exerts force attraction on an object then object will also exert the same amount. Okay. Exert equal force on Earth in the opposite direction. Due to action reaction forces, so it will exert in the opposite force. Okay.
Yes, sir.
Opposite. Here, everyone, please do let me know.
Yes,
Yes,
sir.
sir.
Okay. So you must see this thing that when you drop a stone from a height, so it's like we see this thing that a stone is dropping. It's basically stone is falling from a height, but we do not see this thing that Earth is moving upwards. because the amount of force generated by the stone is very small as compared to Earth, because Earth is a very massive you can say body. So that amount of force or acceleration is very like it's negligible. It's almost zero in the context of Earth. Am I clear to all of you? Please let me know everyone.
Yes, sir.
Yes, sir.
Okay? Chalo, that's great. Because so I'm just writing it. The mass of a stone is very small due to which gravitational force produces a large acceleration. Yeah, because force is there, so acceleration would be there. So it will produce a large acceleration, not that much large, but yeah, that is visible and observable. Okay, and
Yes,
due
sir.
to the A is equal to F by m. So here mass is very small in the Earth case, in the body case. So that means that if this is small, the acceleration produced would be large. Due to the second law of motion, force is equal to ma, right? So A would be F by m. But in the case of Earth, due to the massive size of Earth, that is not visible at all. Clear, everyone?
Yes, sir.
Yes, sir.
The mass of Earth is very, very large. Okay, it's very large. So same gravitational, because force is same due to action reaction forces. So force produces the gravitational force produce very small acceleration in Earth. Clear, everyone?
Yes, sir.
Right. So we can easily see the like a stone is dropping from a height, but we cannot see that basically the Earth is moving upward. Right. It's very extremely small. Clear, everyone?
Yes, sir.
Any doubt so far to anyone?
No,
Please
sir.
do let me
No,
know.
sir.
So this is basically the Newton's third law of gravitation, Newton's third law of motion and the gravitation relationship. Like it is also applicable, it holds good, right? So it gives the scenario, like so why don't we see the basically the same basically the gravitational force, you can say consequence on Earth. Okay? So now let's do one next topic, that is the free fall. Okay, that is free fall.
Sir, can you show the
Yes,
means?
acha, okay.
Sir, can you show the last point?
Acha, last point. Okay. Tejas, where were you since last 3 classes?
Yes, sir.
Where were you since last 3 classes?
I was outside and I was having exams also.
Okay. How's the exam?
Sir, can you
Great,
show
great,
this?
sir.
Okay, that's yes. Is Aisha, you said something, Vijay?
Sir, can you show that full sentence? The last
Uh,
one.
the last one. This which one?
Yes.
This one.
Sir, finish.
Oh, sure. Just a moment, everyone. I just need to see one thing. Just a moment. One thing from the old notebook. Do you have buoyancy and Archimedes principle?
So let me check.
Please check as well.
Yes, sir, I'll check. So what to check? Can you
Just a second. Yes, please tell me.
yes, sir,
So
what
what
you
should
told
I
to
check?
check?
I said that you have buoyancy and Archimedes principle in your syllabus.
I'll check and tell.
Buoyancy. Sir, buoyancy and
Buoyancy.
okay. Yes, sir. Buoyancy, yes.
Chalo. Density.
Yes, sir.
Mm.
Because these are the topics like some schools basically scrap these topics. School have these
No,
topics.
sir. Sir,
Chalo,
I'll see, sir.
ठीक है. अरे चलो, okay, कोई बात नहीं. Please find out after this class. Let's do the question. Let's do the next topic. That is the free fall topic. ठीक है. Right. So now you can see this thing. What does it mean? Free fall. So free fall means, suppose that everyone that suppose you must have seen skydiving. Have you seen in the movies and the in any video skydiving? Skydiving basically you basically jump out from a plane from a very great height. अरे कुछ तो बोलो. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
It seems like it's like, and that's not good. At least respond to me, na. Only two said yes. Have you seen or not? Just tell me, yeah, so that I can show
Yes,
it to
sir.
you if you haven't seen that. अच्छा, ठीक है. So basically that. अच्छा. Hmm. Okay. Okay then. Okay.
Okay,
So
sir.
okay, that's for everyone. Tejas, Farhan, and Safiya. That basically when you jump from a very high height or great height, so your body is falling without any external force, right? Only you are falling under the gravitational force. That motion is called free fall. When you basically fall under the influence of the gravitational force, that fall is called free fall. Am I clear to all of you? Please do let me know.
Yes, sir.
Yes, sir.
Yes, sir.
Right?
Yes,
So
sir.
that is called free fall. Okay. So let's write it over here. That is what is free fall. So basically, Tejas, you have just missed one topic. That is the universal gravitation topic. Okay. The last
Okay, sir.
they started in the last class. So you
Okay,
do one thing. First, watch the recording. So if you are able to understand it, then it's well and good. If you're not, so you can also do. Okay. So you
okay,
have two
sir.
options. Whatever option you would like to choose, you can choose. Okay.
Okay, sir.
Sure, that's great. So because that will help you to understand the concept in a very early, like in a very fast manner. Because if you have just at least some knowledge from the previous topic, so you can easily understand in the revision class. Okay. First
Yes, sir.
watch the recorder, then schedule the class because that will help you to understand in a very fast manner. Okay.
Okay, sir.
Okay. So next, so basically the falling. Of a body from a height towards the earth under the gravitational force under the gravitational force of earth. Yeah. The condition is that with no forces acting on that. Okay, so there should not be any force except the gravitational. Okay. It's called free fall. So basically, when the ball is dropped from a height, so that is also a same case because there is no external force except the gravitational force. So that's why that motion will also be considered as free fall. Please do let me know, everyone, if it's clear to you or not. Do you have any doubts?
Yes, sir, it's clear, sir.
So clear, sir.
That's it. So skydiving is also an example for basically dropping a ball from a height, right? Dropping a feather from a height. So these are multiple examples that you can assume from your own. Okay, everyone?
Yes, sir.
Yes, sir.
Chalo. So one more thing, everyone. So basically, you know this thing that when the body is falling towards the surface, so the acceleration given by the Earth is same for all the body. It is not different. Like if like that, suppose if you drop a stone, if you drop a feather, if you drop a stone and if you drop a feather, so the acceleration given by the Earth will be same. Okay.
Sir.
Yes. Anybody still said something? Anyone? Anyone? Do you have any doubt? Anyone?
No, no,
No,
no doubt.
sir.
There it is. And nobody basically asked me, sir, why feather basically takes longer time than stone. Even basically acceleration is same. They should basically you can say uh, fall with the same speed, or it should take same amount of time. But still, feather takes a lot of time basically to come from a first floor height as compared to stone. Yes or no? If you drop a
Yes,
feather,
sir.
if you drop a stone, feather will take more time to reach the ground. But nobody basically give the attention to it.
Sir,
I thought that
because feather is lighter. So feather is lighter and the gravitational force pushes it away, which makes it slower to come
according
towards the
to
ground.
force of gravitation, this is the formula. Lighter
Yeah.
the mass, higher the acceleration. It should basically you can say it should reach the earth, the surface faster than stone. Stone has very high mass as compared to feather. It's like 10,000 times than feather. Yes or no?
Yes, sir.
But the
Yes,
reason
sir.
is that because that reason is not there. But still, I'm telling you just for the knowledge. You must have seen that feather is like this. Like I'm not good in drawing. Just please pardon me for that. Okay. So just like this. This is like the feather now. So as you can see this thing, everyone, that the feather has a plain area. Like the area is very big as compared to stone. Stone is like this. The area is very compact in the stone. Yes or no?
Yes, sir.
So in that case, if in the real life, we are talking about real life. In that case, feather basically feather will have more air resistance because air is present in the atmosphere. So air will basically does not allow the feather to move it easily. But as the stone has very compact size, very small size, you can say shape. So that's why it can easily penetrate the air resistance and it will reach the surface earlier than the feather. The surface area plays the role in that. Okay? So acceleration produced by the earth is same, but the time taken is different due to the size, due to the surface area, due to the shape. Okay? That is not the part of the syllabus, but I'm telling you for the logical building. Okay?
Yes, sir.
Chalo. Because in the stone, mass is concentrated because it's a solid, it's concentrated in a very compact manner. Okay? The acceleration of an object falling freely towards the earth does not depend on the mass of object. Okay? Here everyone.
Yes, sir.
Yes,
Sure.
sir.
That's great. That's great. Okay. It means that the acceleration produced in all the bodies would be same, irrespective of their masses. Okay? The acceleration produced in a freely falling body is same for all the bodies. Okay? Tejas, please come out of the, you can say, the northern light. We are in the class.
Yes, sir. What's
I'm saying that please, like if you are done with your exploration in the worldwide phenomena, so please come out of these and attend the class attentively.
yes, sir. Yes.
Okay? Because you are a good student, but the thing is that you have a lot of distraction, you easily distract. So that is not good for you.
Yes, sir.
And it does not depend mass of the falling body. Please do let me know everyone if it's clear to you or not.
Clear.
Any doubt so far to anyone?
No
No,
doubts.
sir.
Chalo, that's great. Okay. Now in this basically there is a hero comes into the scenario that is called acceleration due to gravity, that is G. Small g, right? Let me write the topic, free fall and acceleration due to gravity, right? So the another topic that we are going to discuss because free fall is like just the, you can say, the statement, but the applications of free fall are basically like are very diverse. Okay, so let's do that. And this is a very important topic, everyone, because this involves the equations of motion from the first chapter. We are going to modify the equations of motion for the gravitation. Okay? Clear, everyone?
Yes, sir,
Yes,
please.
sir.
Chalo, that's it. The next topic that we are going to discuss is acceleration due to gravity. So gravity produces acceleration because that's why it is called acceleration due to gravity. Or you can say this thing, the gravitational force, because gravity is nothing but a force. A pull is what for a force, right? So that's why it's nothing but a gravitational force. The force, sorry, the acceleration produced by the gravitational force, that is called the acceleration due to gravity and small g, and it is very, very important. It's very important. Okay, clear, everyone?
Yes, sir.
Yes,
Yes,
sir.
sir.
So let's write down the thing first. So when the body is dropped from height, everyone, so that body is under uniform acceleration. I've told you in the motion chapter as well, when the body is dropped, so that is under uniform acceleration. And when the motion is free fall, na, when the body is dropped from a height, so that body is under uniform accelerated motion because gravitational force is acting on it. If there is a force, so there will be acceleration. So that's why it will be called as uniformly accelerated motion. Clear, everyone? In this, we are going to discuss the motion part, equations of motion. So it's very important
Yes.
to understand this thing. Is it clear to you, everyone?
Yes, sir.
Yes.
That's it. Okay. So when the body an object is dropped from some height, a uniform acceleration is produced in it in a gravitational pull of force. Okay. And I've told you that, of course, and this acceleration does not depend this acceleration does not depend on mass of the body. Okay. Falling body, that is falling. Okay.
Yes, sir.
This chapter is very important because the concepts are completely new. Okay, so that's why I'm requesting to all of you to please and please understand this properly. Okay,
Yes, sir.
and this constant acceleration is called as uniformly acceleration due to gravity. Okay.
Yes, sir.
A uniform acceleration produced in a free falling body due to the gravitational of force of Earth called acceleration due to gravity. Okay. Clear, everyone?
Yes, sir.
Yes,
Sure.
sir.
So the value of G is 9.8 meter per second square or equal to 10. Okay. The value of so basically it is for the Earth. Okay. So we are talking about Earth because we live in Earth. That's why we are just talking about the value of Earth. But the value of moon, the gravitational with the acceleration due to gravity for moon is different. For Jupiter is different. So it depends on the mass of the planet. It basically the mass of the planet and the radius or the size of the planet defines the value of gravity, acceleration due to gravity. So we are talking about Earth, so that is 9.8. This is an acceleration, so that would be meter per second square or 10 meter per second square in some of the question. In some of the question is basically given to you that it is 10 meter per second square. Okay, just for the ease of the calculation. Am I clear to all of you? Everyone, please tell me.
Yes,
Yes,
sir.
sir.
It means that
Yes,
when a
sir.
body is dropped from a height, so that undergoes an acceleration of 9.8 meter per second square or 10 meter per second square. Okay, everyone? So it will not
Yes, sir.
increase or decrease. It will remain same throughout the fall. Clear, everyone?
Yes,
Yes,
sir.
sir.
That's it. So, quote is body is dropped from, dropped freely. It falls with an acceleration of 9.8 meter per second square. Okay, everyone?
Yes, sir.
And when a body is thrown upwards, it means that if you throw a body in the upwards direction, so it will go under the retardation, because if you throw that body in the upwards direction, so the acceleration will continuously decrease, because at a certain point, the value of the acceleration would become zero, because the ball will stop after reaching the maximum height. So the continuously decrease of the acceleration is there. That's why the ball is stopping if you throw that ball in the vertical direction. Yes or no, everyone?
Yes, sir.
Astiswa, Tejas, Sara, Safiya, and Irshad. Clear? Farhan?
Yes, sir.
Yes, sir.
Chalo. Okay. So it means that when a body is thrown upwards, it is under the retardation. It means that the velocity will continuously decrease. Okay? And when the
Yes,
body is dropped downward, not dropped freely, so it will undergo acceleration, because the velocity will increase. Because when you drop a
yes,
body,
sir.
it will continuously increase the, unless it is basically collide, unless it reaches the ground. So there will be some velocity, right? Clear, everyone?
Yes, sir.
Yes, sir.
So in your syllabus, there is no, you can say, the derivation or the calculation of G, only the number is given to you, the value of G is given to you, right? So, but I'm telling you one thing, that the value of G depends on the mass and the radius of the planet, of the body, you can say. So we are talking about Earth, so Earth has 9.8 meter per second square, but the Jupiter has more than Earth, because Jupiter is very, very large than Earth, right?
Yes, sir.
Okay. So now
Yes,
let's
sir.
take about, so, okay, that's it. So basically one thing is that, you know, that basically value of G decreases, because if we take, basically if we go in the like 100 kilometer above the surface of the Earth, so the value of G will not remain same, it will decrease. And if you basically go inside the Earth, it means that suppose you have basically drill a hole inside the Earth, right? So if you go in the depth of the Earth, the value of G also decrease right there. Okay?
Yes, sir.
Am I clear?
Yes,
Yes,
sir.
sir.
Yes,
Chalo.
sir.
Okay, so now we are talking about the value of G. So these notes are very important, everyone. Please, okay, concentrate. The distance from the Earth increases when we go, okay, when we go up, okay, from the surface. Okay, Tejas, I will. Tejas, the reason is that gravitational force, because it depends on the mass. According to universal law of gravitation, the product of their mass defines the value of force of gravity. Right? So if
Yes, sir.
every body has different mass, every planet has different mass, so that's why the
Yes, sir.
gravitational force exerted by every planet would be different. So that's why the acceleration produced by that planet would be different. Okay, I will
Okay,
send the note pages, no need to worry. Okay,
okay.
as you go from the surface of Earth. Okay, the value of G will decrease. It means that value of G will decrease as the height increases. Okay, this is a very important basically factor affecting the basically this is a property of the value of G, right? And as we go inside the Earth, the value of G will also decrease. Okay, just inside the Earth. Okay, value of G will decrease. Clear, everyone?
Yes, sir.
Yes, sir.
That is the basically the variations of G. Okay.
Yes, sir.
Okay. So
Yes,
the
sir.
maximum value of the acceleration due to gravity is the surface of Earth, the point where we basically are we exist, right?
Yes, sir.
The last point is the value of acceleration due to gravity G maximum on the surface of Earth. Okay.
Yes, sir.
Or the surface of Earth, it decreases so it will decrease ongoing. On the Earth or going inside the surface of Earth. Please do let me know, everyone, if it's clear to you or not.
Yes, sir. It's clear, sir.
Yes, sir.
Okay? So that
Yes.
will decrease and increase according to the place. Okay?
Yes, sir.
Okay. So as I've told you that acceleration due to gravity does not depend on the mass of the body. It means that if you throw a heavy stone and a very light stone, like if the stones are there, so it will reach the point at the same time. But we are talking about, as I've told you that like the your feather and a